So first of all, just wanted to say welcome to everybody who's here, and it's really lovely to see everyone. And special welcome to Dr. Molly Gebrian. I don't know if that's how you say it. Yes. I think many of you know of her work, but just briefly, she's a viola player, and she's also a doctor in neuroscience. And the best thing is that she combines both things for us to understand better things like practice and what goes behind the scenes in our brain to when we do it properly and when we don't do it so properly, and why some practices are more efficient than others. And that's something that fascinates me in general, and I know some of you as well. And I always talk about it, but having somebody who's a real expert in this, I think, is an extra bonus. So I'm going to let her introduce herself properly. So welcome, Molly. Welcome to the this talk.
Thank you so much. Thanks for having me. It's great to see everybody from all over the world. I love doing stuff like this and just meeting musicians from everywhere. So yeah, a little bit more about my background. I am a violist. And as an undergraduate, I double majored in viola and neuroscience, and the neuroscience was truly just for fun. I had no plans to go on with any of it. I just thought it was fascinating and I wanted to learn about it. But then after Oberlin, I went to New England Conservatory for my master's degree. And I found that I really, really missed neuroscience in a way that I don't know, I just didn't feel right not doing neuroscience stuff anymore. But I was at a conservatory, right? So I can't really go like take neuroscience classes. So I was very fortunate that when I was a student at NEC, they allowed me to do a number of independent studies looking at aspects of music in the brain that I had become interested in at Oberlin. And that's when I really started combining it. But again, it was just for my own like personal interest. Um, then I went to Rice University for my doctorate, again in viola. But because I was at a research university, I was able to take graduate level neuroscience classes the whole time I was there. I worked in a lab for a long time. I did a lot of stuff at Rice. I'm very grateful that Rice let me do that, even though I was technically only there as a violist. So for the last 10 years, I have been a college viola professor, but I also used my background in neuroscience to apply the science of learning and memory to practicing and performing. I just 2 months ago moved back to the Boston area, and I now teach at New England Conservatory. I'm teaching classes and workshops and working one-on-one with students on the science of practicing stuff that I do. So I'm really excited about this new chapter in my life. I've been presenting on this stuff for a long time now. I wrote a book that came out this summer on this, and yeah, it's great to be able to do this kind of as my full-time job now. So that's me in a nutshell. That's where I come from. I should also say that I was a Suzuki kid growing up. So I grew up in the Heart Suzuki program in West Hartford, Connecticut, my hometown, which is a very well-known Suzuki program. And I was Suzuki teacher trained as a teacher. I was a Suzuki teacher for many years before I started teaching at the collegiate level. So I also have that Suzuki background, also. So let me go ahead and share my screen and we will get started. Yeah, I will talk for roughly an hour. It always takes something around an hour, but then we'll have plenty of time for discussion and questions at the end. You can feel free to put questions in the chat as I'm going, although I won't look at them. I found it's kind of cumbersome for me to try to look at everything at once when I'm sharing my screen, but we'll have time to answer all your questions at the end. So before we get started, here's an overview of what we're going to talk about today. So first, we're going to talk about some basics about how the brain learns. Then we're going to talk about something called blocked versus random practice. I always say that this is the most controversial part of this presentation, but it's not at all controversial in terms of the science. It just goes against how many people were taught to practice. And so musicians, if they've never heard of this before, are sometimes kind of taken aback by it. Then we're going to talk about how to use a metronome. So unless you've seen one of my presentations before or read about it in my book or something, you don't know how to use your metronome. Then we'll talk about the importance of sleep in learning, and then finally mental practicing. So that's the plan for today. Okay, so if you ever took any sort of psychology, biology, neuroscience class in any of your education, this is probably a familiar image. If not, that's fine too. So on the left here, you are looking at a picture of a neuron, the cells in our brain, and the blow up down here is showing what happens at the synapse. So the synapse is the tiny little space in between two neurons where all the magic happens in your brain, essentially. Anytime that we want to do literally anything at all, the neurons in our brain have to communicate with each other. And that communication starts as a chemical signal. So the first neuron will spit out neurotransmitter into the synapse. And there's lots of different neurotransmitters. Adrenaline, serotonin, and dopamine are the famous ones that you've probably heard of, but there's a whole bunch more. Doesn't matter what they are, they're just chemicals. And so the first neuron spits out neurotransmitter into the synapse. And if the neuron on the other side of the synapse has receptors that are the right shape and size, the neurotransmitter binds to those receptors and causes an electrical change in the second neuron. The analogy that's often given here is between a lock and a key. So the lock is the receptor, the key is the neurotransmitter. If the shapes match, the key goes in the lock and unlocks it. In this case, the unlocking that happens is that electrical change. So that electrical change, that electrical charge, goes flying down this long arm of the neuron that sticks out here. It's called the axon. And when the electrical charge gets to the end of the axon, the process repeats itself. The neurotransmitter spit out, binds to the receptors, causes an electrical change. So all of the communication in our brains is a chemical signal that gets translated into an electrical signal that gets translated back into a chemical signal, and so on forever. Essentially, that's what's going on in your brain all the time without ever stopping, as long as you're alive. In order to learn anything or get better at anything, there have to be physical changes in the brain, including changes at the synapse. So there's lots of different changes that can happen. It doesn't really matter what they are for our purposes. But the first neuron can spit out more or less neurotransmitter. The second neuron can take away the receptors or put out more receptors or put out different receptors. There's also things that function kind of like vacuum cleaners that come and vacuum up the excess neurotransmitter. So you can modify how often the vacuum cleaners do their jobs. But hold on to this idea that changes at the synapse are necessary for learning, because we're going to come back to it later in the presentation. So obviously, doing something complicated like playing an instrument, it's going to be more than just two neurons communicating, right? Hopefully, it's more than just two neurons communicating. And when you have a whole bunch of neurons communicating, it's called a neuronal pathway, a pathway of neurons. And I really like that language because it leads me to a useful analogy. So I'm going to set up my analogy, and then we will come back to brains. Okay. What you have to pretend you're looking at right now is a giant field of snow so big that if you are standing on one side, you can't see what's on the other side. On one side of this snow is someplace bad, someplace you don't want to go. People who have seen me give this presentation before or variants of it know that this is known as the dirty socks. If you haven't seen this before, I need to tell the dirty sock story so I don't start talking about dirty socks by accident and have you guys be like, what is she talking about? So years ago, this is probably like 15 years ago at least, I was giving a version of this presentation to a group of middle school students in this huge auditorium. And I got to this part, and this little kid in the back, he didn't even raise his hand. He just shouts out, "That's the dirty socks." And everybody in the whole room, their heads all whipped around in unison. It was like a cartoon or something, and looked at him like, what? And he just looked back at all of us like, obviously, it was the weirdest, funniest moment. It was so strange. And ever since, this bad place has been known as the dirty socks. So I talk about dirty socks as a shorthand, and I'm always afraid I'm going to forget to tell that story. And then people are like, what? Where did these dirty socks come from? So anyway, one side of the snow, someplace bad, dirty socks. You don't want to go there. On that same side of the snow is your house, which is hopefully a happy place, only clean socks there. All of your friends live on the other side of the snow. And this is a new house. You just moved in and you decided you are going to have a housewarming party, but you are terrible at giving directions. So you send out a text message invitation to your friends saying, hey, party at my house tonight. Come on over. It's on the other side of the snow, but nobody's ever been there. They can't see to the other side of the snow from where they are. And the only pathway through the snow is this one. So your friends, unfortunately, are going to end up at the dirty socks, right? They don't know any better. They see a path through the snow. The invitation just says, hey, go through the snow. They follow the path and they get to the wrong place. In terms of brains, this would be like a neuronal pathway that results in something you don't want. So thinking about music, wrong note, wrong rhythm, bad sound, like whatever it is that's not working on your instrument, if that's the neuronal pathway you have set up, you kind of have no choice. It's not going to come out the way you want. Kind of like your friends, they don't know any better, right? They're just going to follow the pathway that's there. Our brains are the same. Our brains don't know good from bad. They just know what pathways are available. Now imagine that there's this second pathway that goes straight to your house. In brain terms, this would be like everything comes out exactly how you want. When I do this presentation for students, I say, this is like you go to your lesson and you play so well that your teacher says, literally, I have nothing to say. That was fantastic. See you next week. We all know that's never going to happen, but that's sort of what we want our students to strive for. So if you imagine that your friends are confronted with these two pathways, they're essentially the same, right? They don't know. They've never been to your house. They don't know which is which. Probably some of your friends are going to decide to take the pathway on the right and they'll end up at the party, but other of your friends will decide to take the pathway on the left and they will end up at the dirty socks. In brain terms, if you have two essentially equal pathways, it basically means that you have a 50-50 shot of it going well. And I don't know about you guys, but when I get up to perform in front of people, like a 50-50 shot, that doesn't feel good at all, right? That feels like so nerve-wracking. It could be amazing, or it could be the most embarrassing thing ever. When I get up to perform, what I want is this, right? One pathway, I can trust that, yes, I can play this, it's consistent, I'm confident in my ability to do it. The way that you accomplish this single pathway with your friends is you get out your shovel and you shovel over the pathway over here to the dirty socks covered up with snow so nobody can see it, and then nobody takes the pathway and they end up at your house. The way that you accomplish this with your brain is your brain notices when particular pathways aren't being used and it dismantles them while you're sleeping. Actually, our brains are very smart. It notices, hey, this pathway is not being used. This is a waste of resources. Let's get rid of it. But that only happens if you don't use the pathway. So at this point in the presentation, I like to ask about how people typically practice. You can answer for yourself right now or yourself when you were younger or how you think your students probably practice. But I want you to raise your hand if one of the two following ways that I'm about to describe sounds like you or your students in the practice room. So way number one, you start at the beginning, play until you make a mistake, you fix your mistake, and then you go on until you find another one, you fix that one, you go on until you find another one. Raise your hand if that sounds familiar to you, either in your experience or your students' experience. Okay, yes, lots of hands. Okay, way number two, start at the beginning, play till you make a mistake, start over again, and try to do it that second time without a mistake. And then again, play until you make a mistake, start over again. If that one sounds familiar, raise your hand, also hands. Great. When I do this presentation for students and I say, do you practice in one of these two ways? Students raise their hand and they're very eager to be like, yeah, that's how I practice. And so I say, well, it's a good thing I'm here because both of those ways of practicing are hands down the worst possible ways to practice if you actually want to get better, right? And the reason behind it is because even though you've made a mistake, right? In both cases, you stop, so you recognize that you made a mistake. Even though you made a mistake, you just walked down this pathway to the dirty socks. You just reinforced that dirty socks pathway. And so your brain thinks, oh, look, we're using this pathway. It must be important. Let's keep it. And you're like, no, please get rid of it. But again, your brain doesn't know good from bad pathways. It just knows what you're using. And so if you've just used it, your brain's going to keep it. And so when we practice, we need to practice in such a way that we are not walking down the dirty socks pathway repeatedly. And both of those ways of practicing, play until you make a mistake, are doing exactly that. It's a little bit beyond the scope of the presentation today for me to talk about specific practice techniques in terms of to play in tune, do this, to play faster, do this. But I'm going to put a PDF in the chat. For years, I've been sharing my PDF called The Amazing List of Practicing Techniques, which is 8 pages of stuff to do other than start at the beginning, play to make a mistake, and then whatever. That is available for free on my website. But instead of that, what I'm putting in the chat is Appendix A from my book that just came out, which is every single practice method I list in the whole book. It's much more comprehensive than my amazing list of practicing techniques. This is also available for free on my website. Oxford University Press, the publisher of my book, made it freely available for anybody. So there it is for you. It's everything in the whole book. It's the Cliff Notes version of the practice techniques in the book. that being said, me not discussing specific practice techniques, I do want to talk about one right now because it's very germane to this discussion. I'm sure you have heard or potentially given the advice of doing something 10 times correctly, right? To solidify the way you want to do it. And that is potentially great advice, but it has a fatal flaw in it depending on how you do it. So you can imagine a student going into the practice room being like, okay, I need to do this part 10 times correctly to make sure, I fix my mistake, whatever that may be. You can imagine that they do it once and it was great, twice it was great, third time, not so good. Okay, whatever, it doesn't count. Fourth time, not so good, doesn't count. You can imagine that by the time they've done 10 good ones, they could also have done 10 bad ones that didn't count. In which case, they have walked down the pathway to your house 10 times, but they've also walked down the dirty socks pathway 10 times. And so they've accomplished literally and precisely nothing except for wasted their time and made themselves more frustrated because they still have two completely equal pathways. So the addendum that this advice needs is the words in a row. You have to do it a certain number of times in a row to make it stick so that there's a consequence for getting it wrong. You may already be telling your students to do this, and that is great. It seems that the minimum number of times in a row to get something to kind of stick with you is 5. A lot of students will do 2 or 3. That's not enough. So what in a row means is if you do 2, and you mess up on the third one, you have to start over again. You have to go back to 0. When there's a consequence like this for getting it wrong, it makes you focus much more, and it makes you focus on exactly what you have to do to get it right, which is the information you need to recreate it, right, in the future. We're not going to talk a lot about the importance of breaks today. We'll talk about it a little bit when we get to the sleep part, but there's a huge body of research. I have a whole separate presentation on the importance of taking breaks. And the way that I actually do my repetitions now in light of that research is I will do a small number of repetitions, usually 2 or 3, and then I will take a very short break. It's called a micro break in the literature of 10 to 15 seconds. Get a drink of water. I always practice in front of a window, so spy on my neighbors. Just do something to kind of space out for 10 to 15 minutes, allow my brain time to process, and then I do the rest of my repetitions. Most of the time, the way this looks, because I like things to be symmetrical, I'll do 3 repetitions, take a little break, and then 3 more repetitions. If I can get all of those the way I want without having to go back to 0, then I move on to something else, and I'll revisit that later, but I move on. If any of them are wrong and I mess up, not only do I have to go back to 0, but I up the ante on myself. So now instead of 6 total with a break in between, I have to do 9 total. So 3 groups of 3 with little breaks after every 3. I have found that putting these micro breaks in really helps solidify it much better than before I put the little breaks in. So that's how I do my repetitions, and that's how I make sure I reinforce the pathway going to my house far more than the dirty socks pathway. Okay, so we talked about how the brain sort of gets rid of pathways that aren't being used. The brain also notices when pathways are being used a lot, and it does what I call supercharging them. In terms of your friends, this would be like installing a moving sidewalk or something for them. In terms of your brain, what's actually happening is that long arm of the neuron that we talked about, the axon, that the electrical signal goes down. The axon gets wrapped up in something called myelin, which you may have heard of before. Myelin is just a layer of fat which wraps up around that axon, and it allows that electrical signal to move more quickly and more efficiently down the axon. When you have a myelinated pathway on the outside, that skill or whatever feels automatic. So for all of you here, writing your name is automatic, right? You can write your name while you're listening to me talk. You don't have to think about how to spell it. You don't have to think about how to make the letters. But for those of you that have young children in your lives who are just learning how to write, it's hard to write your name at first, right? You really have to concentrate on how to make the letters and the order that they go in. That's because when you're just learning how to write, those pathways aren't myelinated yet. But then as you practice writing your name and other things, the pathway gets more and more myelinated until it becomes really, really easy and automatic. So when we're practicing, we want to be myelinating the correct pathways, right? So that our playing skills feel really easy. What we really have to protect against, though, is this, right? Myelinating the wrong pathway. So this is what underlies bad habits. That's why they feel so just easy to do, even if you don't want to do them. It's because the pathway is myelinated. They feel really automatic. The way that myelin works in the brain is once the myelin is on there, once you've put a wrap of myelin around the neuron, It's on there. There's no mechanism to tell the brain to take it off. And the more you go down a pathway, the more wraps of myelin get put around the axon, and it just makes the information travel much more easily. This isn't to say that you can't break bad habits, definitely not. But what it means is if you have a bad habit you're trying to break, or if you have a student, you're trying to help them break a bad habit, they have to create a new pathway, and they have to make sure they never do their old pathway. So if I have students that are, say, changing something with their bow hold, I tell them, like, even when they're tuning, even when they're sight reading, even when they're messing around with their friends, they have to make sure that they are doing their new bow hold so that they create a new pathway and they're not further reinforcing the wrong pathway. One sort of question to ask yourself when you're practicing that I think goes a long way against protecting against this, myelinating the wrong pathway by accident, or even just reinforcing the wrong pathway, is the question, which pathway am I reinforcing now by how I'm practicing? I think that question can really help us not fall into bad habits by accident. I'll say it again. Which pathway am I reinforcing right now by how I'm practicing? I want to tell a quick story. This was about 10 years ago now. There was a cellist who was really struggling, and her teacher felt that it wasn't a playing issue per se, that it was something about how she was practicing. So he sent her to me. And so the student came to me and I said, "What's the issue?" She said, "It's my intonation. I just can't play in tune. I don't know what I'm doing wrong." And so I said, "Okay, can you show me how you work on intonation?" And she said, "Well, I go slowly so I can hear what I'm doing." I said, "Okay, good, fine." And she said, "If it's out of tune, I adjust it." And I said, "Okay, that's your problem. You are practicing adjusting rather than teaching the finger exactly where it needs to go down." So she thought she was doing good work, but she was reinforcing the adjusting pathway, right? Rather than the "this is precisely where the finger goes down" pathway. And so I think if you step back and ask that question, which pathway am I reinforcing right now? Then you can see more clearly, oh, no wonder she was playing out of tune. She was reinforcing the wrong pathway, even though on the surface of it, it seems like she was doing good work. You're out of tune, you should adjust. Not if you're trying to train your finger where exactly it should go. So I am always asking myself that question in the practice room. If I've been practicing something for a while and it's just not getting better, and it's, I take a step back and I ask myself, okay, what am I trying to reinforce here? Has my practice method been doing that, or have I been doing something else by accident? And almost always I discover I've been doing something very slightly adjacent by accident, but not actually what I want to reinforce. And then I change how I'm practicing, and lo and behold, it works a lot better. Okay, I want to switch gears now and talk about blocked versus random practice. On the surface of it, I feel like this contradicts everything I was just talking about, but it definitely does not. And hopefully you'll see that by the end of this discussion. Before we get into this, I just want to define some terms so we have a common vocabulary. Blocked practice. An example of blocked practice, these are viola orchestra excerpts, but they could be anything. An example of blocked practice would be Don Juan for 30 minutes. Why is this not advancing suddenly? There we go. Mendelssohn Scherzo for 30 minutes. Beethoven 5, second movement for 30 minutes. So you do each thing for a block of time, focus on that thing before moving on to the next. An example of random practice, and as we'll see, there's lots of ways to do this, would be Don Juan for 10 minutes, Beethoven for 10 minutes, Mendelssohn for 10 minutes, Beethoven for 10 minutes, Mendelssohn for 10 minutes, Don Juan for 10 minutes. You guys get the idea. In the end, you've done everything down here for 30 minutes total, but it's been 10 minutes at a time, all mixed up, constantly switching between things. So on the face of it, this seems like a terrible idea, right? This seems extremely chaotic. Like, pick something and just focus on that thing. Stop switching all the time. What you're doing, it's just too chaotic, and it's not going to work. However, the science is extremely clear that random practicing is far superior, particularly for performing well. And that's how I'll talk about it today. But there is also substantial research that you can learn more quickly when you do random practice. But I find that this is particularly powerful for ensuring you perform the way you want to perform. I find that musicians are sometimes skeptical about this. So what I like to do is share a handful of studies with you, and then hopefully make you a little bit annoyed with me, like, yeah, I've got the point. All right, tell me how to do this in my practicing. So I'll share some studies, and then I'll give you some practical advice on how to implement this. All right, the first study that I like to look at was done on baseball players. And the point of the study was to increase their batting average, how many balls they could hit. They split the baseball players into two groups, the block practice group and the random practice group. The blocked practice group got 45 total pitches in blocks of 15. So they would get 15 fastballs, then 15 curveballs, then 15 changeup pitches, and they had to hit as many as they could. The random practice group also got 45 total pitches, but the order was completely random. They never knew what was coming at them, and again, they had to hit as many as possible. While they were practicing, the blocked practice group looked like they were doing better, which makes sense, right? They knew exactly what they had to hit, and they just had to do it over and over. The random practice group had to adjust on the fly, so it makes sense that they wouldn't do as well. But when they brought the baseball players back 2 days later for a performance, in our terminology, they found that while the blocked practice group had made a 25% improvement, the random practice group had made a 57% improvement, which is obviously a lot more improvement. For those of you that like graphs, here's a graph for you where it says acquisition down here. That is the practice session. And you can see the block practice group is doing better than the random practice group. Where it says transfer test over here, that's the performance. And you can see they switch, right? Now the random practice group is on top and they're doing better. Often musicians are a little skeptical that this will apply to music, right? Hitting baseballs is a very different thing than like playing a piano concerto or something like that. It just seems like music is far more complicated. So to see whether this actually works in musicians, we have a study that was done on pianists to directly test this. So in the piano study, all the pianists came into the lab to learn a series of short pieces that were composed specifically for the experiment. So nobody knew them ahead of time. These were pieces that were too hard to sight read, but not so hard that you'd have to practice them like forever and forever. And these were all professional pianists. All of the pianists learned all of the pieces. Some they learned using a blocked practice method. Some they learned using a random practice method. The experimenters controlled that aspect of it, so we don't really have to get into experimental design. But anyway, they learned all these pieces, 2 different practice methods. Like the baseball players, while they were practicing, it looked like they were doing better on the pieces that they were learning using the blocked practice method. However, when they came back 2 days later and they had to play a concert of these pieces, just like the baseball players, the pieces that they had learned using a random practice method, they performed much more successfully. So same exact result. My favorite part of this study is after the concert was over, they interviewed all the pianists. And one of the questions they asked was, what do you think is better, blocked or random practice? And all of the pianists were like, oh, definitely blocked practice, no question. And I was like, wait, what? Like they could see for themselves that the random practice resulted in a better performance. Why do they think that block practice is better? But that result, thinking that block practice is better, even when it's very clearly not, that's so common that psychologists have given it a name. They call it the illusion of mastery. And I love that because if you only do blocked practice, it gives you the illusion that you've mastered it, but you haven't. It's an illusion. This is what is behind that experience of, and I'm sure your students have said this to you, oh my gosh, I promise I practiced this. This was so much better at home yesterday. I don't know what's going on. I promise I can play it. Every single one of you has heard that. Every single one of you probably said that when you were a student, right? We have all had that experience of sounds great at home. And then you go play for your teacher and it's an utter disaster. And it's baffling, right? Because like you could play it yesterday. Why, like right now, does it be like, I don't even know what a viola is. Like, why do I feel so uncoordinated? So the reason for this is when we're practicing, we typically break things down. We'll do repetitions, we'll do it slower. We'll do things a few times, and then gradually we'll put it back together. And then by the end of our practice session, it's feeling a lot better and it's sounding good. And it's like, okay, yeah, I can play this. When we go to a lesson, typically the way it goes is we just play for our teacher, right? And we do like a run through. That is a really different skill for the brain to just play it through, rather than getting to break it down and work on it and do repetitions and slowly work it up. Much more difficult to just play it through. And students are usually doing that for the first time in front of their teacher, which is a high pressure situation. So it's kind of no wonder it doesn't go well, right? Their brain is trying to do a new skill. It's never gotten to practice. It's a difficult skill. It's a high pressure situation. Frankly, it would be surprising if it did go well because their poor brain just didn't get to practice what it's going to have to do. So looking at it that way, it makes a lot more sense why that experience happens so often. The solution to that is random practice, because when you are constantly switching between things, it forces your brain to be much more flexible. It forces your brain to remember sort of at the drop of a hat. Like, what do I have to do to play this thing? Oh yeah, that's right. I remember now. Okay. And it works on those skills that you need in performance of quickly switching between things, right? When you play, you are constantly switching because new sections are happening. But if you don't practice that, how is your brain supposed to do it? So this begs the question, does block practice have any place? So I want to share a study now that was done on basketball players that looked at this. In this basketball study, there were 3 groups. There was a block practice group, a random practice group, and also a group that had an increasingly random schedule of practice. So to illustrate what this third group had to do, I'm going to go back to my orchestra excerpts. So this third group started with blocked practice. So in our example, that would be 30 minutes of Don 1, 30 minutes of Mendelssohn, 30 minutes of Beethoven 5. Then they moved on to something called serial practice. So in our example, that would be 10 minutes of Don 1, 10 minutes of Mendelssohn, 10 minutes of Beethoven 5. 10 minutes of Don 1, 10 minutes of Mendelssohn, 10 minutes of Beethoven 5. You guys get it. So you're constantly switching between things. So you give your brain an opportunity to practice that skill of constant switching and sort of readjusting and whatever to the new music, but it's in a predictable order. So your brain gets used to the switching. And then finally, they went on to truly random practice. So in our example, it would be 10 minutes of each thing, like all mixed up. What they found was that the group that had this increasingly random schedule did the best of all. I have a graph of this for you. I know the 2 dark bars look essentially the same color, but it doesn't matter because all we care about is the light gray bar, which is this increasingly random group. This is showing number of mistakes. So the lower the bar, the better. Where it says immediate retention, that's their performance right after they finished practicing. And then 48-hour retention is a performance 48 hours after they finish practicing. And you can see that this increasingly random group is doing the best of all. This particular study used people learning basketball skills like for the first time. So they were like beginners at basketball skills. And the experimenters in this particular study think they got this result because first you have to solidify the skill doing block practice. Then once you get better at it, you have to up the level of difficulty by doing serial practice. And then finally, you have to test, like, can you do this thing no matter what by doing truly random practice? And I will say for me, in my experience as a musician, this is definitely true. If something's brand new and I can't do it like 5 times in a row, like we were talking about in the previous section of this presentation, there's no way that I can just like pick up my viola and do it on the first try. It's just not solid enough yet, right? It needs more practice first. And so this definitely rings true to me from an experiential standpoint. All right, the last study that I want to share having to do with block versus random practice was one of the ones that made me really say, okay, I really need to start doing this. The ones that I've shared so far, I read, and I was like, oh yeah, that sounds like a good idea. And then I read the one that I'm about to share, and I was like, okay, I'm shooting myself in the foot if I'm not doing random practice. So here it is. This was a study that actually put people in a brain scanner to see what was going on in their brains while they were doing random versus blocked practice. They were particularly interested in 3 different areas of the brain. That's the A, B, C here. It doesn't matter what they are, except to say that these are parts of the brain that are involved in like higher cognitive skills. When people were doing blocked practice, here it's called repetitive practice, their brains were activated this much, you can see how big the bars are, versus when they were doing random practice, here called interleaved practice, but it's the same thing. You can see the bars are way bigger for the interleaved practice. That means their brains are working a lot harder. There's a lot more brain activation. The brain is working a lot harder when people are doing interleaved random practice. Now compare that to over here where it says retention. This means performance. Whenever they say retention, it means performance. When people perform things they learned doing blocked practice, their brains are activated this much, versus when they perform things they learned using interleaf practice, look at those bars. They're hardly there at all. They're almost non-existent. What that means is when you perform something you learned using random practice, it makes it so easy for your brain to perform that thing, your brain hardly has to do anything at all. I saw this and I was like, okay, like I said, I'm absolutely shooting myself in the foot because I don't know about you guys, but when I get up to perform, my brain feels just a little bit discombobulated, like it just doesn't work quite as well. And if I'm only doing block practice, I'm making it harder for my brain than it needs to be in a performance situation. I could be making things really easy for my brain, which is kind of what I would like to happen in a performance. The way to get there is to make it work really hard in the practice room by doing interleave practice so that when I get on stage, makes it really easy for my brain. This is also in graphic form, that illusion of mastery, right? When you're practicing using block practice, it feels a lot easier. That's why you have that illusion that you've mastered it. It's like, oh yeah, this feels easy. I can do it. And then you go perform and your brain has to work a lot harder than it otherwise would. And it doesn't work, right? Okay, so hopefully I've convinced you that this is at least worth trying. And now you want me to stop talking about studies and give you some practical advice. So time for practical advice. This first method of putting this into practice is actually an example of serial practice from this study that had sort of the sort of three steps working up to random practice. This is something I do when I am like a month to 2 weeks out from a performance, definitely by the 2-week mark, but I usually start it 3 to 4 weeks before I have a concert at the beginning, or a series of concerts at the beginning of October. So I started doing this kind of practice last week. So what I do for this is I make a list of my hard spots. I want to have between 5 and 15. We'll talk about why in just a minute. Usually my lists have, I would say, I don't know, 7 or 8 spots on them. They can be within one piece or one movement or across many pieces and many movements. It really doesn't matter. For the ease of my example, I have 5 spots on the screen here. You can see some of these are quite short. This one's just a bar. This one's just a bar. This one's a little longer. I would say for me, the longest they ever are is like 2 lines, like relatively short. So I make a list of my hard spots. And then I perform my first spot as if it's a concert. So I make sure before I play it, I get myself in a performance mindset. I think about what I need to think about, and then I perform it. If I would be happy with how I played it in a concert, it gets a tick mark on the list. If I'm not happy with it, too bad. I just have to go on just like it's a concert. So then I go on to my second spot, perform it. If it's good, it gets a tick mark. Hopefully I go through my list and they all get tick marks. Once I've made it through my list, I go back to the beginning and I play my first spot again. If it's good, it gets a tick mark. If it's not good, not only does it not get a tick mark, but I have to erase any tick marks I've already accumulated for that spot. So I don't remember how I set this up, but okay. So that third one, apparently I messed up the second time through the list. So I lost my first tick mark that I earned the first time through. The goal with this is 5 tick marks on each spot. That's the goal. So it's like doing it 5 times in a row, but it's not literally in a row because you're going 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. This is a great test of how performance ready you are on something. I have on the next slide a picture of me actually doing this. This was not one practice session. This is just several slips of paper over many practice sessions. This is way too many spots to do all at once. Right here where it says Clark 1, that's the first movement of the Rebecca Clark Sonata. Those are my spots. That's usually how long my list is. What's that? Yeah, 7 spots. I don't know if you can tell, but so not all of them have 5, right? That one only has 3, that one has 4. Several of them have like smudge marks behind it, which means I lost my tick marks and I had to erase and I had to start over again. I show this because most of these have 5, but these 2 don't. It's not unusual that, you know, there's like 1 or 2 spots on the list that I can't get to 5 right away because I keep having to erase. When that happens, I don't just alternate between those 2 spots until I get 5. I start a new list with those 2 spots and then spots from something else. The reason for that is we were talking about the importance of taking breaks. In the sort of in the realm of testing performance readiness, you want enough time between performances of each spot to kind of forget a little bit about each spot before you have to play it again. So like after I perform the opening, I have to go perform all these other things. When I get back to perform the opening again, it's not really fresh in my mind because I haven't just played it. So it sort of mimics what it's going to feel like to actually perform it. If you only have 2 spots and you're going back and forth between them, you don't get that, right? Because you just played the spot and then you just go right back to it. So you want to start a new list. And that's why you want to have like 5 to 15 spots. If you have too many spots, it just takes too long, and it wears your brain out. So yeah, I would say this length of list is what's pretty typical for me. Okay, so that's one thing I do. Another thing I do is I use an interval timer. I actually have lots of ways of using interval timers. So an interval timer allows you to set it to go off repeatedly. So like every 5 minutes or something like that. So what I do with this, one way that I use this to test performance readiness is I will pick out something that I want to test myself on, usually just one passage. And then I will start my practice session by practicing something completely different. And I'll start my interval timer. I'm practicing whatever other thing I picked out to practice. When the interval timer goes off, I stop what I'm doing. I performed the spot that I want to test for performance readiness, and then I go back to practicing whatever I was practicing. Timer goes off again. I perform my spot again, go back to what I was practicing. So this also mimics what it's going to feel like to just play it sort of right off the bat without getting to kind of do it. So that is really helpful. Another thing that I do with the interval timer, and this is for learning stuff, not testing performance readiness, I will put on an interval timer that tells me when to switch what I'm practicing. I usually put on a 3-minute timer for this because the shorter the timer, the more focused you have to be, right? Anything shorter than 3 minutes, I find actually too short. But if you're going to do this, I usually pick 3 to 4 spots that I'm rotating between, and you want to come back to each spot at least 3 times. You want to play it, you want to practice it 3 times total. So I guess come back to it 2 times within a practice session, because it's the switching between things and returning to what you were practicing earlier that really helps solidify it in your brain. So I will write out my order. If I have 3 spots, I might do, let's say 1, 2, 3, 2, 3, 1, 3, 1, 2 as my order. And then every time the timer goes off, I switch sort of what I'm doing. It really makes you focus. When you come back to a spot, you have to remember, what was I working on here? And it's really effective. It also doesn't allow you to space out because you have such little time. I have so many more ways that I use this in the PDF that I put in the chat. There's a whole bunch of random practice ideas. So definitely check those out. This is such a powerful practice method. If I had to pick one thing that was a huge game changer for me, it would be this. It would be interleaf practice. So highly recommended to give it a try. Something that I think is important to keep in mind in light of this information is if we want to perform well, we have to let our brains practice what they're going to have to do on stage. And that is not blocked practice, right? We don't get to do a whole bunch of repetitions on stage and then say to our audience, okay, it's going to be good this time. Listen, we just have to do it. And so if you want to be able to do that, that's a skill that you have to practice so your brain knows what it has to do. And so that's sort of the principle behind this practice method. I'm sure you guys as teachers can come up with a whole host of creative ones that I haven't come up with yet, but that's the principle that you want to keep in mind. All right, let's switch gears and talk about metronomes. So this information that I'm going to share with you right now comes from a study that was done on non-musicians, and it put them in a brain scanner, an fMRI machine, to see what their brains were doing when they were doing 2 different tasks. In one of the tasks, there was a metronome on, and they had to tap along with it. They didn't have to do rhythms or anything. They just had to stay steady with the metronome. And then the metronome was turned off, and they had to keep tapping and staying steady. And the question was, what's their brain doing when they're doing these 2 things? So let me explain what you're looking at here. This is a picture of a bunch of brains being viewed from the top down. So like bird's eye view of brains. Any colored blobs are areas of the brain that are active when people are doing whatever they're doing. The S column is showing what people's brains are doing when they are synchronizing their tapping to the metronome. The C column is showing what the brain is doing when they are continuing to tap after the metronome goes off. You can see very clearly that although the S and the C columns are similar, they are not identical, right? There's these blobs here in the C column that are not there in the S column. There's more down here that aren't there in the S column. So what this means is when the metronome is off, the brain is doing something fundamentally different than when the metronome is on. And this explains why you can play perfectly steady with the metronome, your rhythm is excellent, and then you turn the metronome off and you're rushing or dragging or your rhythm gets all weird. It's because it's different parts of the brain. The parts of the brain that are active when the metronome is off are together known as the sensory motor loop. And one of the jobs of the sensory motor loop is to time and pace our motions in the absence of something external helping us, in this case, a metronome. Just like I was just saying about the random practice, you have to allow your brain to practice what it's going to have to do on stage if you want it to work for you. Because we never perform with a metronome on, if you only practice with a metronome, the sensory motor loop does not get to practice, and then it doesn't know what to do to keep you steady when you get on stage. So I see a lot of musicians, particularly wind and brass players, always have the metronome on. Everything they're practicing, the metronome is always on. And I know they think that that is going to make them rock solid steady, but it's going to do the opposite, because their sensory motor loop is never going to get to practice until they're in a performance situation, because they suddenly don't have a metronome, and it won't have good skills because it hasn't gone to practice. So now that you know this about how the metronome works and how it works with our brain, let's talk about how to use a metronome to actually improve sense of pulse. Okay, the first thing to do, I'm going to get my metronome so I can demonstrate this for you. Oh, and I need to turn on my original sound, otherwise it's going to mute my metronome. All right, there we go. First thing is to have the metronome click on off beats only. Can you guys hear my metronome? Yeah? Okay, so tap off beats. And now count with your tapping. 1, 2, 3, 4. 1, 2, 3, 4. Stop tapping, stop counting. It should sound like it's clicking on the ands now. So this is the beat, and the metronome is clicking on the ands. So that's how you turn it around. You tap the off beats, then you count with your hand to turn it around, and then you just play with it on the off beats. If when we all stopped counting and tapping, it switched on you and it sounded like it was on the beat again suddenly, that means your internal sense of pulse is not very strong. And that's not a judgment, it's just a statement of fact. Practicing this skill will improve your internal sense of pulse. Putting on the metronome, tapping the off beats, and then having the counting with your hand, and then silencing your counting and your tapping to see if you can still feel the beat when the metronome's only clicking on the off beat. Okay, next thing to do is to have it click every other beat only. So if you're in 4, 4, 1, and 3, or 2 and 4, then every downbeat only, every second downbeat, every third downbeat, etc. What this does is it puts the beats further and further apart, so that sensory motor loop has to turn on and get to practice, but you still have the objective metronome checking in with you every once in a while to make sure you are actually steady. I also want to share 2 apps with you that have a very cool random mute function. So I'm going to go to the next screen to show some screen shares from the apps. So the Time Guru metronome as an actual metronome I find kind of annoying actually to use, but it has this very cool random mute function that's on a slider. So in the picture here, the slider is set to randomly mute 70% of the beats. I have mine right now set to randomly mute 30%. Oh, I'm blurred. Hold on. I want you to see that it's flashing. Let me, I always just have it blurred, just kind of automatically. There we go. So hopefully you can see that it's still flashing on every beat, so you can look at it to get yourself started, and then just don't look at it when you play, and it doesn't click on every beat. If I slide it up now, it's at 75% random mute. You can see that it's still flashing, but you can hear this is a great challenge. If you play along with this and when it decides to click, you're right on a beat with it, you feel like it's very rewarding. You're just like, I'm the most steady person on the planet. This is great. So this is a great challenge. Time Guru also has a gradual function. So where it says off here, that's a button. And if you tap it, it turns on. And then it will start off with all the beats, but it will randomly mute up to whatever your slider's at, so 70%. So I'll show you this. You can hear that all of the beats are there, and as I let it go, more and more of them will kind of fall out. There they start going. And it's random. It's different every time. So this kind of weans you off the metronome being on every beat. I want to share Tonal Energy too, because this is a very popular metronome tuner app. To get to the random beat silencing in here, it's in the metronome portion of the app, and you click on this little robot guy, and then this metronome assistant menu pops up, and there's a random beat silencing option. If you turn that on, if you press the slider, then you get this little bar that you can set. So same thing as Time Guru. This is set to mute 71% of the beats. It has an option to always play the downbeats, which I think kind of defeats the purpose of the random beat silencing, so I don't turn that on in Tonal Energy. I also want to show you how, with my metronome, how I get the metronome to click every third downbeat. Let's say I don't have my metronome at some ridiculously slow tempo. I put the metronome on my tempo, in this case 80, and I put it on a meter with a whole bunch of beats, in this case 12/4. In this metronome, when the beats are dark blue, they make a click sound, but if you tap on them, they turn light blue and it silences them. So I silence all of the beats except for the first one. So if we were in 4/4, this would be like 1, 2, 3, 4, 2, 2, 3, 4, 3, 2, 3, 4, click. So that's how I get it to click. Flashes, so you can look at it to get yourself started, and then just don't look while you're playing. These metronome things are really effective at improving rhythm and sense of pulse. I do this with all my students eventually. Some of my students absolutely hate this when we do it in lessons. They always like complain about it. You clearly see how effective it is, or you wouldn't recommend it to your friends. So stop complaining. But it works really well. If you've never tried this, I find it really fun. I find it a really fun challenge to try to make sure I'm right with the metronome when it's not clicking every single beat. So highly recommended to try it out. All right, let's switch gears again and talk about sleep and learning. I'm gonna get a drink of water. Before I get into this research, I want to share a book that I always share, and that is Why We Sleep by Matthew Walker. Some of you may have heard me talk about this book before. Dr. Walker is one of the leading neuroscientists in the study of sleep. This book came out, I want to say in 2015 or 2016, definitely within the last 10 years. And it's fascinating. It's so interesting. It has such good information. It will change your life when it comes to sleep. I can't say enough good things about it. It's also on Audible if you're an audiobook person. Okay, so the information that I'm going to share about sleep comes from a series of studies that was done by Matthew Walker, not on Matthew Walker, in the early 2000s, looking at the effect of sleep on motor learning. So in these studies, he had people come into the lab and they had to learn to do a button press sequence as quickly and accurately as they could. So first, they had 12 training trials, that's what this means down here, where they learned what order they were supposed to press the buttons in. And you can see that as they do their training, they get gradually better, which is what you expect, right? When people practice, that you get better. After they'd finished their training, then 6 times throughout the day in groups of 2, they had these little retests of this button press sequence, where they had to perform the sequence as quickly and accurately as they could, and they were measured on how many they could do within 30 seconds and how accurate they were. This diagonal line that's going through, that's the prediction line, predicting how much better people will be as they continue to practice. You can see that when they do these retests, they're like mini performances. You can see that they're like a little, right? They still just kind of continue to get better in a way that's predictable. So this was just basically showing like, yes, when people practice, they get better. Great. So then Dr. Walker and his colleagues sent them home, and they said, go home, get a full night of sleep, come back tomorrow, and we'll test you again tomorrow. When they came back the next day, it was no longer a linear progression. It was a huge jump in performance. So in these graphs, the black bars are their performance on day 1, same thing as you just looked at. The gray bars are their performance on day 2. The top graph is showing speed. The bottom graph is showing number of mistakes. You can see there's a very big jump in performance, right? Between day 1 and day 2, both in terms of speed and accuracy. They're way faster. They're way more accurate. So Dr. Walker and his colleagues were like, okay, that's cool. What if we have the amount of practice they're able to do on day 1? Do you still see this big jump on day 2? And in fact, you do. When people did half the amount of practice on day 1, they still had this big jump in performance on day 2. So then they said, okay, what if we have it again? What if we only do the training trials, like the bare minimum? What happens on day 2? You see the same big jump on day 2. And in fact, I know you can't read these teeny tiny little numbers, but if you could, you would see that the people that did the bare minimum amount of practicing achieved the same level of performance on day 2 as the people that did essentially 4 times as much practicing on that first day. So this seems kind of like magic, right? Like do a little bit of practice, go home, go to sleep, and the next day you're like a lot better than you were on the first day, and you did much less practice. You just went to sleep. So why does this happen? That's always my question. I like to practice, but I really like to sleep. If I can get better just by sleeping, like I'm going to take that option. So they had one more group of people sleep over in the lab so that they could try to figure out what's going on. What they found was, and we're going to break this down so you understand it, but what they found was there was a very strong correlation between the amount of improvement they made the next day and the amount of time they spent in something called stage 2 NREM sleep in the fourth quarter of the night. What in the world is stage 2 NREM sleep in the fourth quarter of the night? Because clearly that has something to do with this. Okay, so you guys have probably heard of REM sleep, rapid eye movement sleep, right? So the opposite of REM sleep is non-rapid eye movement sleep, or NREM sleep. So that's the NREM part of this. The stage 2 part describes how deeply they were sleeping. So stage 4 sleep is very deep sleep. Like that's what's going on when you sleep through your alarm. You are dead to the world. Stage 1 sleep is very light sleep, very, very easy to wake you up. So stage 2 is on the lighter side, but not the lightest kind of sleep. So that's the stage 2 part. And then to explain this fourth quarter part over here, sleep scientists consider a full night's sleep for adults to be 8 hours, and they break it into 2-hour quarters. So the fourth quarter is the final 2 hours, hours 7 and 8, in a full night of sleep. I want to highlight this because all of you getting 6 hours of sleep or less, you can't get this benefit because you're not reaching the fourth quarter. Okay, so come back to that in just a sec. Coming back to this graph, again, they found that there was a very strong correlation between the amount of improvement people made the next day and the amount of time they spent in stage 2 NREM sleep in the fourth quarter of the night. Now you know what all that means. So this word correlation, I'm sure you've heard the phrase correlation is not causation, right? Just because two things are related, you can't say one causes the other because it could be some third thing that's causing both of them. In this particular case, they think this relationship is causal, that the more time you spend in stage 2 NREM sleep in the fourth quarter of the night, that causes more improvement the next day. The reason they think this is based on other sleep research. And that other sleep research has found that all of that synapse changing activity that we talked about at the beginning when I said, in order to learn, you have to have changes at the synapse. Hold on to this idea for later in the presentation. Now is what you need that information for. There is a peak in that kind of synapse changing activity that underlies learning, particularly during stage 2 NREM sleep in the fourth quarter of the night. So when you spend more time in this type of sleep, you allow your brain more opportunity to make those changes at the synapse, and that translates into better skill the next day when you try it again. So how can you use this? First off, you need to get enough sleep. Like I said, if you're not getting 8 hours of sleep, if you're not reaching that fourth quarter, you're not going to get this benefit. Our brain does a lot of stuff in the final hours of sleep that are really, really important for learning. Second, is this explains why cramming doesn't work particularly well, right? I tell my students all the time, it's much better to practice just 10 minutes every day than 70 minutes once a week, because you get that boost in learning every night. You get 7 boosts from sleep rather than just 1. And like we saw from this study, doing extra practice doesn't give you an extra boost. So you might as well do a little bit every day, get a boost every day. By the end of the week, you'll be at a much higher level than if you only did it once. I mentioned breaks earlier. Sleep is the ultimate break. Our brains really, really need the downtime of sleep to process what we've learned during the day. And what we get the next day when we get enough sleep is a higher level of skill. And so we don't have to work as hard, which is always very nice. Okay, final topic, mental practicing. So this study that I'm about to share with you was also done on non-musicians. These people had never played any instrument ever, and they had to learn how to play this on the piano. You guys can read it. And the goal was to do it at quarter note equals 60 in 16 notes. So group 1 of these non-musicians had to practice just this 2 hours a day for 5 days. Can you imagine just that for 2 hours? 5 days at the piano. Group 2 had to practice this 2 hours a day for 5 days, mental practice only, even worse, right? They just had to sit there. They weren't allowed to move. They weren't allowed to make any noise. And they had to just imagine themselves playing it. They had to like feel their fingers move, but in their imagination for 2 hours every day for 5 days. Okay. And then the third group was the control group. They didn't get to practice. So the only time groups 2 and 3 got to actually play a real piano was for 2 seconds at the end of each day when the experimenters tested how well they were doing. So what did they find? The control group did not practice, did not get better. So if you want to get better, you have to practice. Thank you, science. All right. Physical practice group was perfect. They better be, right? They practiced that thing for 10 hours. That's hopefully not a surprise either. The mental practice group, after 5 days, was approximately where the physical practice group was after 3 days, which is pretty impressive. Remember, these people have never played any instrument ever, and they're just doing it by imagining it inside their head. So the experimenters told the mental practice group, okay, go into a room with an actual piano, go practice for 2 hours, and then come back and we'll test you again. And when they came back, they were also perfect. This is not the thing that totally blew my mind about mental practicing when I first read this study. The thing that blew my mind is something I didn't tell you about yet. So in addition to testing how well they could play the piano, they were also looking at people's brains, because around the time this study came out, a different study came out that found that the part of the brain that controls the left-hand fingers in string players, the hand that we use on the instrument, the part of the brain that controls our left-hand fingers is bigger than the part of the brain that controls the right-hand fingers and then like the general population. We now know that any body part you use intensively, the way string players use, we use our left-hand fingers, that part of the brain gets bigger to support that skill. It's due to practicing. So any pianists here, the part of your brain that controls the right hand and the left hand is bigger than the general population. You may have seen videos on YouTube of people that play piano with their feet. So for those people, the toe area is bigger, right? Because they're using their toes in a really sort of specialized way. So based on that research, in this mental practice study, they hypothesized that the part of the brain that was controlling the fingers in the physical practice group would grow bigger over the course of the study. And then the question was, would there be any change in the brains of the mental practice group? So what did they find in that regard? Control group did not practice, did not get better, their brains didn't change. No surprise there. In the physical practice group, they found exactly what they thought. Obviously, this is not a brain, it's just a schematic diagram, but you can see that the part of the brain that they're measuring gets bigger and bigger and bigger over the 5 days, exactly like they thought it would. Here's the thing that totally blew my mind. The part of the brain that controlled the fingers in the mental practicers got bigger to almost the exact same extent as the physical practicers. Think about that for just a sec. These mental practice people changed the actual physical structure of their brain just by thinking about it. You can't do that like out in the world, right? I can't sit in my house here and be like, you know, I really wish this room was a little bit bigger and have the walls push out and the ceiling go up or something like that, right? You cannot control your physical environment in that way. That would be some sort of crazy superpower. But you can change the actual physical structure of your brain with your brain, which is just the most amazing thing ever. The reason this works is when you mental practice, you're using the same parts of the brain as when you physical practice in almost exactly the same way. It's not 100% identical, because if it were, you wouldn't be able to tell the difference between physically doing something and just imagining it, which I think would be very weird not to be able to tell the difference. But the only difference in the brain activation is due to not actually doing it. But other than that, it's the same. So how can you use this? So anytime you want to practice and you can't, you can mental practice. So if you are traveling and you're in a plane or a car or a bus or something like that, you can mental practice. If it's early in the morning or late at night and people are sleeping and you don't want to bother them, you can mental practice. If you're injured and you can't play because your body won't let you, you can mental practice. In fact, the research on mental practice shows that the combination of mental practice and physical practice together is far better than either one by itself. So if you're only doing physical practice, you're not getting the full benefit as you would if you did both mental and physical practice. So often I get asked, well, what do you mean by mental practice? What I mean by mental practice is imagining everything you need to be aware of when you're actually playing. So you want to hear what it sounds like in terms of pitch, in terms of quality of sound, in terms of phrasing, expression, everything that goes into the aural realm of music, being able to hear it the way you want. And you want to be able to feel yourself do it the way you want. So all the physical details you have to be aware of when playing your instrument, you want to be able to imagine that. Anything that you can't either you can't imagine or you can imagine and it's wrong, you can fix in your brain. If you play something in your brain and you make a mistake, you can fix that mistake in your brain and then it will fix it out when you do it on the instrument. Often when people are new to mental practicing, it can feel very strange to start. It takes practice to mental practice, and often things aren't so clear in your imagination at first. I always advocate for people to start with one thing, one aspect of playing that feels like it will be clear. For some people, that's imagining what it sounds like. For other people, it's imagining like feeling their fingers move in the right order and in the right place. Whatever it is, start with that thing and just a little tiny bit of music and see if you can imagine that thing clearly and the way you want. Once you can do that, add a second thing. So for me as a string player, maybe I will imagine what my fingers feel like, and then I'll add on imagining what my bow feels like and trying to do those together. So one thing at a time. If it's hard to imagine and you really can't imagine it, going back and forth between playing and imagining is very effective. So if it's hard to say, hear what you want it to sound like, play it on your instrument and then try to imagine it. Then play it, then imagine, play, imagine. And going back and forth in that way can help clarify your imagination. So that's the end of the presentation part. So I'm going to stop my screen share so we can talk and have a conversation. Goodbye to people that have to teach. So I would love to hear what questions you have. You can either type them in the chat if you don't want to say them. You can raise your hand, whatever you want to do. I would love to hear your questions.
Yeah, hi. If nobody has a question, that's like very fascinating. So thank you for all of this. Just like a question about the last topic. How does this work in relation to like, because we involve like physicality, muscles, and there is a thing like stamina that is involved in learning something new. And, and I understand that there are some aspects which we can work out, but I'm assuming that like simply the physical act, the stamina is not something that can be so easily like made up for by mental practicing. Or am I getting this wrong? Like, this is just interesting, because there are those different aspects.
Right. No, you are right. I'm going to add some nuance to this, but you are right. Physical stamina needs to be practiced. Physically, you couldn't just imagine running a marathon and then you'd be able to run a marathon because you wouldn't have the physical stamina. That being said, they have found that when people mental practice, there is actual muscle activation in the muscles that are involved in doing it. And you can actually strengthen muscles by imagining yourself lifting weights. Isn't that wild?
Wow.
Yeah. So there is physical activation in the muscles that you would be using. So there's that. The other thing I would say is often, so in performance, if stamina is an issue, right? If we have a really tiring piece or a really, really long piece, there's physical stamina and there's mental stamina, right? Mental practicing will really help with the mental stamina. And what I have found for myself and my students is if they don't have the mental stamina, it often finds its way into their bodies in terms of increased tightness, and then that makes the physical stamina more difficult because they start getting tight and tired because their brains are getting really tired. So if you can improve the mental stamina through mental practicing, it often does have an effect on the physical stamina in kind of an indirect way.
This is really fascinating too, that actually, like to think in that way, that the physical tiredness comes from the mental, and wow, that's really like refreshing.
But yes, you do, like I said, I have a series of concerts at the beginning of October. It's a big program for me. I've performed it many times at this point, and I always have to work my stamina back up because it's very physically tiring. And the first few times I run the program, I'm like, God, how do I do this? This is so tiring, like physically, just because it's so much music. But then, I get my stamina back up. So you absolutely have to do the physical aspect, but I think we underestimate the importance of the mental aspect in physical stamina.
Yeah, it seems like we definitely do.
Thank you for that question. There's a follow-up. Does that mean you can correct physical tension with mental practice? Yes, it does. Thank you for asking that. So actually, let's try this as an experiment right now. I assume all of you have something in your playing where you always get tight. Maybe it's like something really high or something really fast, and you know you get tension in your shoulders or your neck or something like that. I want you to imagine yourself playing that right now, but also imagine, I'm going to use shoulders as an example because it's just a very common one. Imagine while you're playing this hard thing that you can feel your shoulders being very broad and very open and just very sort of free, and see if you can imagine that in your shoulders or wherever your tension is and the playing at the same time. I'll be quiet and let you try that for a minute. Okay, were you able to imagine it either without tension or with less tension? Okay, so what I find is sometimes students can't. They can't imagine it without tension, which means they definitely can't play it without tension, right? So you can work on imagining what it feels like to play without tension. And then once you've imagined that clearly, it's much more easy to actually do that. I also find that sometimes students are able to be more aware of physical tension when they imagine playing something. I have students mental practice a lot in lessons. The way that I do this in lessons is we'll be working on something and I notice that something's not working for them, and I suspect that mental practicing will help. And so I'll say, okay, I want you to do, this set of bars, whatever, mental practice, and imagine yourself, playing it the way you want. Or, I draw their attention to like really feel what your bow's doing. And it's not unusual for my students to be like, oh my gosh, I realize that when I imagine this, I'm like weirdly tight in my arm here, and they'd never felt that before. And so then I have them imagine it without that tension. And then they're much more aware of when that happens on the instrument. It's interesting how that happens, that awareness can come in without actually physically doing something. So yeah, great. Other questions people have?
I definitely
Everybody's tired because it's late at night there.
Yeah,
yes, please.
Are they coming, the questions, or you don't have them? Oh, okay, Guillaume. Yeah. Right.
I have a couple of questions from block versus random practice. The first one, you kind of answered it, but I wanted to know whether blocked repetition is still good for new things, or is it still better to use random repetition in those cases?
Yeah, that's a great question. So what the research shows is when something is new, we're not very good at it yet, and it's very unstable. And if we introduce too much randomness or variability into how we're practicing it, it's not helpful because it's already kind of all over the place. And so when I am learning something new, the very beginning of like the practice life of a piece, I'm doing almost exclusively block practice, or more block practice, let's say. And then as I get closer to a performance, it shifts to more and more and more random practice until, like right now, I said I have a concert in about a month. That music, like I'm really only doing random practice on that. I'm not doing any like block practice on that. That being said, the research is clear that you will learn much more quickly, and it will like cement it in your brain much more durably if you do random practice from the beginning of learning something new. So the way that I do this with new stuff. So what I used to do is something new, I would practice it for however long I was going to practice it, and then I wouldn't touch it again that day until it was time to practice it again tomorrow. Now what I do is I practice it for a little bit, and then I go work on some other stuff, and then I come back and I practice it again a little bit more, and then I work on some other stuff, and then I practice it again. This, what I just described, could happen all within one practice session, or it could happen within various practice sessions like throughout the day. So I do it in the morning, and the afternoon, and then the evening, just as an example. That works a heck of a lot better. It is not my personal preference. Some people like to constantly switch between things. Their brains just like that variety. My brain does not like that, and so I have to make I have to make myself practice in that way. But it's very, very clear that it works a lot better. I learn music a lot faster that way. It sticks with me a lot better. So if you need to schedule the switching like I do to make sure I do it, do it. Because even at the beginning, it does work a lot better.
Thank you. Anna.
Great. Let's do Anne. Oh, sorry.
Anna was first, I think.
Okay.
Yeah, it's like it's funny like getting used to these thoughts, because like there's so much like now being taught about the short attention spans and how we, like I guess we all encounter this problem of even like ourselves constantly being disturbed by something and not being able to hold your attention on something for like longer amounts of time like it was in the past. Yeah, and this is being like told often as something negative. And here, yeah, it is quite challenging to adjust your way of thinking to the fact that actually this randomness, yeah, may be so beneficial. Yeah.
Right.
Because what's the how does it actually work with the attention span? I would like instinctively think if I dedicate my time for a bit longer to something like that, we even say like we go deeper into a certain task, like you allow yourself to step deeper and like understand. So yeah, I understand this works, the randomization, for like certain stages of learning. Yes, and that's how you explain it. But yeah, but that's also interesting, the attention span.
Right. And it's true that we do have to work on mental stamina, like we were talking about before, right? And so for students who do really struggle to focus on something, that's a really useful skill too. The way that I usually advocate people practice that is to set a timer for a very short amount of time for which they are sure they can focus for that amount of time. Maybe it's only 1 minute, but fine. 1 minute timer, you are focused for that time. Once the 1 minute feels easy, then maybe you're going to try 2 minutes or 3 minutes and gradually increase the timer during which you're focused, and that will increase your capacity for being able to do that.
Yeah, that makes sense. Yes, thank you.
Yes. Anna, and then Catherine.
Yes, hello. I'm just wondering how to, because I'm a Suzuki teacher, obviously, and how can I implement this for my kids? I mean, this is interesting because the wee ones, they only have like this attention span, so you have to jump around, and because that's how they learn. And so my question is how do we introduce these good methods to our students in a good way?
Yeah, great question. So I was a Suzuki teacher for like 10 years before I started teaching at the collegiate level. So I taught lots of little ones also, and I thought about this question a lot, right? So the first thing I would say is with teaching little kids, it's always a good practice to embed everything into games, right? Because kids love games, and there's lots of research that shows that not just kids, everybody learns better when things are embedded into a game. So I made all of these things into games with the little ones who, you constantly have to switch anyways. I make sure that I always come back to things. So for instance, when I first introduce like the bow hold, right, I'll introduce it maybe at the beginning of the lesson, and we'll do it for 1 minute or something, and then we'll go, do other stuff, and then we'll come back and we'll do bow hold again, and then we'll go do other stuff and we'll do bow hold again. So I have to, especially with little ones where you really have to switch a lot, I have to do a lot more pre-planning to make sure I know what I want to have in the lesson. I know what the priority is, and that I'm constantly coming back to things so it gets reinforced, because the amount of time you're doing any given thing is so short. In terms of other games I play, like with the random practicing, I had all sorts of games that I played with kids in terms of like If they were preparing, let's say, to play in a recital and they had like their polished piece, right? I would have something where they would just like pick things out of a hat and it would tell them what to play. They're doing this scale, or they're doing this piece, or they're doing this portion of this piece, whatever. I also use interval timers in the lesson. And so with the example of polished piece is a great example of this too. I would set my timer usually for every 5-ish minutes. Every time the timer went off, we would stop whatever we were doing. They would have to perform their polished piece, and then we'd go back to having our lesson. It's really, as a teacher, you have to really remember what you were doing before you switch to the polished piece, because the timer's going to go off in the middle of you talking about something, and you have to hold on to that while they play their polished piece and then come back. But it's really, really effective. In terms of doing repetitions, like we were talking about with the pathways, the game I play, I'm so bad at coming up with names, but it's called the dice game. And they would roll 2 dice and they would get 2 rolls, and they had to choose one of the rolls. So maybe they rolled 7 and they rolled 5, and they chose one of those, and that's how many repetitions they had to do in a row to get it correct. It's a very simple game. Anything lower than 4 is too low, so it doesn't count. They have to roll again. Even the little ones recognized pretty quickly that this game worked really well to help solidify stuff. I would have little ones like march into their lesson the way they do sometime. They'd be like, Miss Molly, we need to play the dice game today because I'm having a hard time with low 2, or whatever it was. And I was like, okay, we can play the dice game. I also, if they would roll like 2 really high numbers, like if they rolled like 12 and 10, I would always give them a deal. And the deal was, if they could get 5 in a row without having to go back to 0 at all, they could stop at 5 and they didn't have to do the rest of their repetitions. It's hilarious how well this makes them focus. And I would always I'd say, okay, if you want a few practice rounds to, get my help, make sure you know what you're doing before we start counting, you can do this. And they were much more invested in their repetitions then. What's interesting is what starts to happen after they've done this for a few years. Kids who would, always take the deal, after a while, they'd get to 5 and they'd be like, no, I want to challenge myself. I want to see if I can get all the way to 12, or they'd start picking the higher number, which was kind of really fun to see. But yeah, embedding things in games as much as possible, thinking, okay, what's the principle behind this practice method? How can I make this into a game that feels fun? For the kids is how I implement it with them. Does that answer your question? Great, thank you. And you got home. I'm glad you got home. And Catherine, go ahead.
Hi, thank you so much. It's so interesting and so inspiring. I came up with a question. I'm not quite sure if it really belongs here, but I want to ask nonetheless. Now we were talking about the physical aspect of the playing, solving technical problems, right, with the how to practice it. But I often find it, and this works for me when I play orchestra stuff, that I go to the spots and I work this, but I often find it difficult when I play a program with various solo pieces in a row with different character. Mm-hmm. I can play them technically, but sometimes my head is a bit behind. It's still in the other piece, or it's maybe in what I'm gonna have for dinner after the concert. So yeah, that's how I am. But do you also practice how to switch your emotions, and how do you practice this, and when do you start to practice or to take this along in the practice? Because
that's a great.
I think for me, often this is the most difficult thing in a performance, to be
in the piece
from the first note, or
right,
even right on there in the different mood, in the piece.
Yeah, no, absolutely. This is a great question. So random practice absolutely will address this issue. Especially the ideas for testing performance. It's really important when you do that you're constantly switching between sections, especially the interval timer thing. When the timer goes off, you go perform your thing. It's very important when you do that you think what you want to be thinking in terms of the musical aspect of it and what you're trying to express before you start playing, because you're making a mental habit of, this is what I think before I perform this piece. the discussion of the pathways, it's very easy to conceive of that in terms of like technical means, like physical aspects, but our brains work exactly the same way with thoughts. And so if you make thinking through, what do I want to be doing musically in this piece, a thinking habit that always happens before you start the piece, then you will do it automatically when you get up to perform, because it will be part of the process of performing the piece. So all the mental practice, all of the random practice ideas will really, really help with that. Something that I do, and I especially do this for orchestral excerpts because they're so short, and when you take an audition, like you just have to switch really, really quickly. I do this for orchestral excerpts. I sometimes do it for solo pieces, but you can do it for anything. At the top of my music, if I'm using music, I have 3 to 5 bullet points of the things that I want to make sure I think before I start to play. And sometimes with excerpts, sometimes these are technical things, like I really have to remember this thing with my bow or whatever. But if you've noticed your issue is like being in the music and actually like expressing it and being in the world of the music, your bullet points should be something that helps you get into that mindset. It might be like words that sort of evoke particular emotions or images or whatever, but think through your bullet points. You want them to be like very short, like 1 to 3 words that you can read very quickly, or if you're playing from memory, you can hold in your memory. And once you have these, when you're doing your random practice to test performance, make sure you like read through and think through your bullet points before you start, so that becomes part of the practice. In terms of when do you integrate this into your playing, I would argue it should be there from the beginning. Because when we learn music technically and musically as 2 separate things, that's when they get separated from each other. And technique is musicality, musicality is technique, right? Like you can't play musically unless you know what you're doing technically. And so they should be integrated from the start. And if they're integrated from the start, it's harder to just play without having like the musical aspect there for you, because it's so embedded in what you're doing physically. So that would be my answer for that.
Thank you.
You're welcome. Kari, go ahead.
Yes, it's so interesting what Anne-Katrine is saying. Can you hear me?
Yes.
Yes. Because like with students, you see, even with the same repetition and the same practice regime and help, it's so much easier for some students than for others.
Mm-hmm.
So it must have something to be with the neural states in the children and the stress levels, or something. Like if you practice with tension, and maybe you cannot see the tension even, but it is still there, like the interference.
Right. Absolutely. No, you're exactly
to work
right.
on that as the basics must be some of the most important.
Yeah, no, I agree. And in my teaching, all of my students know I ask so many questions when I'm teaching, because I'm constantly trying to get at what's going on in their mind, what's going on in their body. Like the thing, I can observe a lot, but there's a lot that you can't observe, right? That's going on up here. And I am always trying to figure out what they're thinking that's not helpful, or what they're not thinking that they should be thinking. I'm always asking questions like that, because I'm trying to figure out where are those weak links that it's making them tight, or they're not, in the mindset they need to be playing this piece, because all of those things are skills that need to be practiced, and students often need to be told that they are skills, and they need to be told how to practice them. So yeah, but you're absolutely right. Some students have an easier time than others, but it's because the ones who aren't having an easier time, nobody has given them appropriate instruction on, what they should be doing in their minds a lot of times, and how to work on that skill.
Mm-hmm. And then additionally is like you're talking about these micro breaks.
Mm-hmm.
Often we tell the children to focus,
Mm-hmm.
but maybe it's good then. Those
Yes.
actually, maybe they need it. How did
Yes.
all zoom out? It's actually necessary for their nervous system to be able to learn. So maybe we should not yell at them for that.
Yes.
Or
no, I have a couple things to say about that. One is All brains, every single person's brain needs to space out. When we space out and we're not paying attention and we're just sort of daydreaming, that's called the default mode network. That's the default mode of our brains. We need to space out. Our brains need to do that. It's a biological necessity. And so when you space out, it's not a bad thing. It's necessary. Some people need that more than others. And often when we yell at children to focus, their brain is doing what it needs to be doing to take care of itself. And yelling at them to focus is not helpful. We often also yell at neurodivergent students to focus because they're doing something that's helping them focus, but it looks like they're not focused. And so if you have a child with ADHD, for instance, they need to move to focus. They need to fidget to focus. And by telling them to sit still, you're making it harder for them to focus. Autistic students have a really hard time focusing if they're looking in your eyes. So telling someone, look at me, focus. They can't focus if they're doing that because it's really difficult to look someone in the eye when you're autistic. Those are just a couple of examples. And so learning about the different ways in which different people focus, I think, is really important as teachers. Neurodivergent students often need to stim a lot, which means like moving around. I've had a lot of neurodivergent students in my life, and I always tell them, if they disclose to me that, you know, they're autistic or they're ADHD or whatever, I always tell them, you are very welcome to stim as much as you need to in your lessons, because they've often been shamed for that their entire life, told, sit still, pay attention, stop moving, stop blah, blah, blah. They cannot focus that way. It's like literally impossible. And the relief students feel when they can stim in their lesson and move around and shake and do whatever they need to is enormous for them, and it helps them learn a lot better. And so if you've noticed this in your students, if you've noticed that you have fidgety students and you're constantly saying like, sit still, pay attention, focus, they are trying to focus by moving the way they are. And we aren't helping them by trying to get them to sit still, because that's not how they focus. You can tell I'm very passionate about this subject. So that would be my answer to that.
But it can be stressful for me as a teacher to have this fidgety student, and then my stress comes into their system again. But if I manage to just accept it,
exactly,
it's not always good to know what is
right. Exactly. I mean, I also find it. I find some stims quite distracting to me, but my attitude when I'm teaching is my job is to help my student, and it's their education, and I can manage myself so that I can still focus on what I need to, and I can manage my whatever I may be feeling because of their stimming, because if I stop them from doing that, they're not going to be able to learn from me. And so it's my responsibility as the teacher to do what I need to do to keep myself calm and focused so that they can be the person they need to be in front of me so that they can take in what I'm trying to say. So it takes practice. I had a student whose stim was plucking out little melodies on their viola when I was teaching. It was really distracting to me to have them plucking and making music. And they noticed once, they were like, this is distracting to you, isn't it? And I was like, yes, but I'm getting used to it because clearly it helps you. And they were like, yeah, like I focus so much better when I can just be like playing little things. And so I just had to practice getting used to it.
And then one more question.
Yeah.
Like with the repetitions, can repetitions be bad in a way? Also, if it's like build up like you don't trust your system to just deliver what you know you can deliver?
That's a great question, that by doing repetitions, you start to second guess whether you can like actually do it. This is going back to the mental things we've been talking about. It's really important when you're doing repetitions, if you notice that there's sort of that sort of doubt creeping in, that you build in the self-talk that you want to be having when you're playing that piece. And so if you notice you're starting to doubt yourself, part of the repetition needs to be saying something encouraging to yourself, like, yeah, I can do this, or I know I can do this, or I know where this shift is, or whatever it is that's helpful to say. And so part of the repetition becomes not only doing it correctly on the instrument, but also saying the supportive self-talk to yourself at the same time, so that becomes ingrained in the physical skill. So then you say it to yourself when you go to perform it.
It's because I remember, for example, my son, he told me, Mama, I already know how to do this. I don't need more repetitions. And then I pushed him to do more repetitions, but maybe he was right.
Right. I mean, if you can do something and you know you can do it and it's fine, you don't need to do repetitions on it. Right? If something is fine, you don't have to repeat it. And repeating it will likely make it worse for the reason you said. You want to do repetitions on things to solidify things that aren't solid, right? But if something is fine, leave it alone.
So then with Suzuki repertoire, then I have this doubt again. Is it those repetitions when I have already learned the pieces?
You got a little quiet in the middle of that, and I think I missed part of what you said.
With the Suzuki, I'm also a Suzuki teacher. With the Suzuki repertoire, we want our students to repeat the old piece,
right?
To grow the myelin.
Right.
But actually, can it not be? Should we stop asking them to repeat so much? Actually.
Yeah, I was a Suzuki kid too. I remember. I never did my review. I hated doing review. So I do think that Suzuki students do too much review, and it is not in line with the research on learning and taking breaks. What works much better, what the research on taking breaks shows, is as you get better at something, you want longer and longer breaks between doing it. You want to take more and more time off. And so often the way Suzuki review is done is everything's in a constant sort of cycle and you're like constantly coming back to things. But what's more aligned with the research is older pieces should be reviewed less. And when they're reviewed less, they actually stick with you better. Something else that helps with review is that every time you come back to it, you're not playing it just to play it, but you have a different focus. So maybe you're trying to play it musically in a different way, or maybe you're applying some new skill you learned to this old piece. So yeah, changing the schedule of review, I think, is a necessity, in my opinion. But also changing the focus of why am I reviewing this? Yeah. Great. Anna, go ahead.
Yes. I have a question because I have a couple of students that when I ask them either to do something or choose something and they just go quiet. And you can really see that they're thinking. And I just I learned I don't remember who told me this, but I realized that sometimes I have to really just sit still and let them think and count to 7 or something. But I thought this was only for for small kids. These two students, that one of them is I think 11, and the other is 15, and they're both they're siblings. And the other sibling is the same way. So I don't know why is this? Why do they need those? You can really see the cogs turning, and they're not stupid. It's just that and I thought this was a small kids thing, but they aren't small kids anymore.
No, it's not a small kids thing. Everybody needs processing time. Every single person needs processing time. And every single person takes a different amount of time to process. We were talking about neurodivergent students. Neurodivergent students in particular need a lot more time to process. It's not unusual for a neurodivergent individual to not actually fully process something that they experienced or heard or whatever until days later, sometimes years later. So everybody needs processing time. And I would say actually as teachers, we don't give our students nearly enough processing time. We're just, like throwing stuff at them all the time. Those students are taking the processing time they need, which is great, but it's not a little kid thing, it's an everybody thing. And as teachers, we need to be sensitive to the processing time our students need. Within a lesson may not even be enough time. They may need time to, deal with it on their own and then come back. So yeah, everybody's brain is different, and everybody's brain takes different times. An analogy I like to use with processing time with the brain is metabolism, with breaking down your food. Some people have a really fast metabolism, some people have a slower metabolism. It has nothing to do with anything. It's just that's the way that your body works, right? So with processing speed with the brain, it's the same thing. Some people process really fast, some people process more slowly, some people process certain types of information really quickly and other types of information more slowly. I process verbal information really fast. You can probably tell because I talk really fast. But I process other information a lot slower, and sometimes it takes me a while to process, and I'm like, why did I just figure that out now? And so it can be really different, person to person. And so yeah, it's my understanding is processing speed and processing time is genetically determined. And so that would be why it makes sense that all the siblings have that same, processing time where they need a moment for the cogs to turn. And yeah, as teachers, if we notice that our students need more processing time, we need to give that to them, right? And what you do, you just, stay quiet and let them process. That's exactly right. Thank you for that question.
Okay, if there's not any more questions, I think we have reached the end and past it. I just wanted to say thank you, Molly, for all the information you have thrown at us, and especially with the Q&A, especially it's been amazing. So yeah, and hopefully we'll get to see you again at some point. For everyone, I will send you more information about how to get more stuff from Molly, because she has a lot more to give.
Yes.
But anyways, thank you so much from everyone.
Thank you so much for having me. I just put my email in the chat. If you guys have other questions or you want to contact me, I also put my website in the chat. I have lots of free resources on my website with the science of practicing stuff. On my YouTube channel, I also have a whole bunch of videos on this stuff. Yeah, I just have a bunch of stuff. I have stuff you can pay me for too, but I have a bunch of free stuff that you can find. Yeah. Did I spell my name right? I did. Okay.